Hey there, welcome back. I'm glad you're here. This is Middle School Math. I'm Dr. K, and today we're going to talk about solving inequalities. Let's jump in. So, an inequality is an interesting thing. It's very much like an equation, but you have a different symbol. So, we're not talking about some things being equal. We're talking about one thing being less than the other, or one thing being greater than the other, or less than or equal to, greater than or equal to, whatever it is. We're not talking about just an equation. What I love about inequalities is you usually solve them after you solve equations, and how you solve an inequality is just like how you solve an equation. So here are some tips from me to you. Now, I want to solve and I want to isolate the variable just like I would in an equation. I find it helpful for my students to draw a line down the symbol, that in this case it's a greater than symbol. In equations, obviously it was an equal to symbol. I know that I need to isolate this variable, so the first step is to get rid of that plus 3, and I'll subtract it from both sides. When I do that, 3 minus 3 gives me 0, leaving me with only a 2x on the left-hand side. And then on the right-hand side, 21 minus 3 is 18. Now, if you've been solving equations for days or for units or for weeks or months, whatever it is, it's really tempting to put an equal sign here. But remember, we're not working with an equation. We're working with an inequality, which means we need to bring down the exact same sign we had. In this case, it's a greater than sign. To finish isolating my variable, I need to divide by 2, which gets that x all by itself. That gives me 1x is greater than 9. Now, with inequalities, we're often graphing them on a number line to show that there are many solutions. So if x represents things that are greater than 9, that means x could represent 10, 11, 12, 20, 50, 92, a million, anything that's greater than 9. So we put that on a number line to represent the infinite number of solutions that there are. So I want to show things that are greater than 9. I do that by first numbering my number line. I always put the number I'm working with, the 9 in this case, in the middle, 2 above and 2 below. Remember that the greater numbers are on the right and the lesser numbers are on the bottom, or on the left. I will circle my 9, and then I just want to point an arrow that goes to the right-hand side to show that I want all of the greater numbers, things that are greater than 9. Here's another example. It's basically the same idea. We're just adding another level of complication. So when you look at this, I hope that you're thinking, first of all, it's an inequality. Second of all, I see that it's less than or equal to, which is going to matter when we graph it. And third of all, there's a number outside of the parentheses, which means there's going to be some distributing. So let's start with that. I'm going to distribute this 5 to both terms. I'll get 30x plus 15. Make sure you do not write an equal sign. We're not working with an equation, right? So it's less than or equal to negative 15. For my students, again, it's helpful to draw that line just to remember that there are two sides to the inequality, and we have to do the same thing on the left as we do to the right. I will subtract 15 from both sides because I'm trying to get this 30x to be isolated. When I do that, 15 minus 15 is 0, so 30x is in fact isolated. On the right-hand side, we have negative 15 minus 15, or you can think of that as negative 15 plus negative 15, which is negative 30. To finish isolating that variable, I need to divide by 30. Oops, there we go, 30 on both sides. That tells me that x is less than or equal to negative 30 divided by 30, which is negative 1. Now, to graph that solution, again, I want negative 1 in the middle, two things that are larger, two things that are smaller. I will circle my negative 1, and this time I'm actually going to go ahead and shade in my circle, and that's because it's less than and equal to. So negative 1 is also a solution. We want things that are less than negative 1, like negative 2, negative 5, negative 90, negative 2,000. Those are all solutions. But also negative 1 is a solution because it says that x could be less than or equal to negative 1. Anyway, that means we need to shade in our circle and then point an arrow toward the left. Here's one last example. I wanted you to see some multi-step situations where you're distributing, and in this case, you're combining like terms. So I'm going to go ahead and draw the line down and get to solving. I see that I have 4x and minus 2x or negative 2x, so I'm going to go ahead and combine those like terms. That will give me 4x minus 2x is 2x, and then I need to bring down the minus 8. My job is to get this 2x isolated, so I will add 8 to both sides. Negative 12 plus 8 is negative 4. Be careful not to put an equal sign. I keep saying it because it happens a lot. And then negative 8 plus 8 is 0, so I'm left with only a 2x. Now, to complete getting that x isolated, I'll divide by 2 on both sides, and I'll get negative 2 is greater than or equal to x. Now, if you know a little bit about graphing inequalities, you might already know how to start this process, putting it on the graph. I find it most helpful for my students to flip around the answer, which means I'm going to go ahead and trade the places of the x and the negative 2. And when you do that, you have to flip the sign to go with it. So you'll notice that my sign is now pointing a different direction. That's because if you think of this inequality as like a Pac-Man or an alligator or a monster or whatever, you often learn in elementary school that the monster eats the bigger thing. So that means negative 2 was the bigger thing. So if I'm going to rewrite it, negative 2 still has to be the bigger thing, and the monster still has to be pointing that direction. Now, to graph this, I'm going to put negative 2 on my number line, negative 1, 0, negative 3, and negative 4. I'll circle my negative 2. And hopefully you already know this, but we're going to fill in the circle, and that's because we're looking for numbers that are less than or equal to negative 2. And because we're looking for lesser numbers, I'll point my arrow toward the left. So here's the big overview, the big idea. You solve an inequality just like an equation. You're really using opposite operations. You're trying to balance both sides. You might have to tune into combining like terms or distributing or using those other skills that you learned in equation solving. The only difference is you don't have an equal sign anymore. You now have a less than or an equal to or whatever. Now, when graphing, remember that it does help to make sure that the letter is first. That's my suggestion. You don't have to. It's just easier to mess it up if you don't. And the goal here is to be successful, right? So that can be helpful. If you do that, if you have to flip an answer around like we did on the third example, you need to flip the inequality and the numbers and the letter. You flip everything. Lastly, remember that you sometimes have filled in circles and sometimes have empty circles, depending on if there's an equal to portion on your symbol. So if it's less than or equal to or greater than or equal to, you fill it in. Otherwise, you leave it empty. So I hope that gives you a start on solving all of your inequalities. I know you've got this. Thanks for being here, and I'll see you next time.